Hi, Heather. I thought I would answer your email via. Oh shoot, I haven't got my ladybug plugged in yet, but he will. She will be here in a minute. Um, your gravitational potential energy is never going to change as long as you're running up to the same height, because it's mass times gravity times h, and I'm going to write it out here as soon as the ladybug turns on. Now, what does change um, is if you, the only way you can make your gravitational potential energy less or equal or anything like that is, all right, once we turn it back on, here we go. I've got to be somewhere at 5:30, so I won't take too long here. I won't waste too much of your time. But anyway, so the gravitational potential energy is equal to your mass times g times h. All right, well, first of all, your mass is never going to change unless you really took a fine measurement of your mass and you change shoes, or you're deciding to wear a weight belt or something like that. When you're going up, the mass isn't going to change. G never changes. So the only thing that can change is the height. And if you ran up as you were supposed to, the same flight of stairs every single time, then your GPA, this never changed. Now, your kinetic energy can change because you have 1/2 mv squared as your kinetic energy running up this. Now, this is running up the stairs. This is up the stairs, running up the stairs. And if you do that faster or slower, if you go faster, your kinetic energy increases. If you go slower, your kinetic energy decreases. What I was talking about in my email was if we drop something, and I don't know if we talk about this in this class, but we do talk about it in my physics sport class quite a bit, where your gravitational potential energy at the start and you drop something turns into all kinetic energy when it hits the ground. And so we just say, okay, well then mgh is equal to 1/2 mv squared, and this is a different this is kinetic energy, but it's different than what we're doing here in this problem. Okay? Does that make sense? Because here, unless you changed your height, which you weren't supposed to do, we were wanting to get how much your average power. The only thing that fluctuated was your V. Here, this fluctuated. And I noticed in your data that it fluctuated. However, when we go to using kinetic energy differently, when we're looking at the total energy in a system, then the gravitational potential energy equals the kinetic energy when you drop something. Okay. All right. So anyway, I hope that helps. I've got to go get somewhere. Okay. All right. I was just reading my email from my friend. Okay, Heather, you're doing great work, and I will talk to all of you later. Probably tomorrow. I'll give a new assignment.